Hi guys, welcome to my YouTube channel. If you're new, you're welcome, and if you're old, you're super welcome. On this video, we're gonna consider how to test one tail one sample hypothesis to investigate a probability statement. But before then, do well to subscribe to my channel and hit the notification bell. Thank you. Without wasting much time, we're gonna dive in to our question. And here we go. An individual claimed that there was a significant reduction in the blood pressure of 10 hypertensive patients after taking a particular drug. If the mean change of the blood pressure of these patients is minus 14 millimeter mercury with standard deviation 14.30, use one-tailed t-distribution to investigate whether to accept or reject this claim at 0.05 probability level, and draw your conclusion about this claim. Right, so there are various steps involved in investigating this claim, and here we go. So step 1 says state the hypothesis. Of course, we have two types of hypothesis. We have one referred to as, so our null hypothesis, right, is designated with H naught, simply implies hypothesis of no difference. So here we go, say equal 0, right? So we state it now. So what this hypothesis is saying is that there was no reduction in blood pressure after taking the drug, right? The next hypothesis we're expected to state is the one referred to as alternative. The alternative hypothesis, designated with HA to be the opposite of null, is not equal 0, right? So what the alternative is saying is that there was reduction in blood pressure after taking the drugs. You could see that the two hypotheses are what? They are different from each other. That is, one is the opposite of the other. All right, the next step is to state the level of significance, right? Of course, looking at our question, the question they say at 0.05 probability level. So our level of significance, represent that with alpha equal 0.05. So step 3 say apply the appropriate formula. Looking at our question, we could see we are dealing with one sample hypothesis of one tail. So we have a unique formula for one sample hypothesis, that is what? One tail. So here we go, t equal mean S over standard error, right? So in our formula here, we could see mean, and we could as well see standard error, right? Looking at our equation, of course, the mean was given, the mean change given to be minus 14 millimeter mercury. So we said that in our formula equal minus 14, right, over, following the formula, standard error. Here, standard error wasn't given, rather we have standard deviation, which is 14.30, right? So it's established that standard error equals standard deviation over root n, right? So is 14.30, right? Then over root n. N here simply refers to numbers of patients. How many patients? We have 10 patients, right? So here we go. We insert that in our formula, root 10, right? So moving forward now, standard error would be 14.30 over, of course, root 10 gives us 3.162, right? So the standard error would be equal 14.30 divided by 3.162. That we have 4.522. Right. So inserting the value we got for standard error in our formula to be 4.522. Right. So our t calculator will be minus 14 divided by 4.522. So our t calc, I call it t calc, would be minus 3.096. Right. Step 4 says the degree of freedom. So I represent that with df because the degree of freedom is n minus 1. Right. So of course our n, the sample size, how many patients we did say is 10. So df would be 10 minus 1, which is 9. So the value of our df equal 9. Step 5 says check for the critical value of t from t distribution table. So that takes us to our t distribution table. So this is our t distribution table. We could see our p, that is the probability given to us, right? Of course, that is 0.05, and we're considering one tail, right? And degree of freedom 9. So we'll trace 0.05 here, right? Then we'll trace it to 9, degree of freedom 9. Of course, our t tabulated, that is the t value on our table, is 1.833, right? So we succeeded in getting our t tabulated from our t distribution table, and the result is 1.833. So we'll move to the next step. So the next step says accept or reject hypothesis. Accepting or rejecting no hypothesis solely depends on t calculated, right? Solely depends on this, and t tabulated, right? So it is established that if t calculated, I call it t cal, of course, looking at the value of our t calculated, we could see that t calculated is greater than t tabulated. It's neglecting the negative sign, and t tabulated is 1.833. So, of course, 3.096 is greater than 1.833. So we reject null and accept the alternative. So here we accept HA, right? So the last step would be to draw our conclusion. So here we go. Conclusion. So since we accepted the alternative hypothesis, and let's see what the alternative hypothesis stated. Alternative said there was reduction in blood pressure after taking the drugs. So let's go. We report this. There was a significant reduction in blood pressure after drug administration. I think we've done justice to investigating this claim that this particular drug reduces high blood pressure, right? And from the result of our investigation, we've been able to draw a conclusion, right? So in our next video, we're going to illustrate how to test two-tailed one-sample hypothesis to investigate a probability statement. Please don't forget to like this video, comment, share, hit the subscription button, and turn on the notification bell. Thank you for watching. Goodbye.